Hello and welcome everyone. My name is Raymond de Jong, Senior Solutions Architect at Isovalent, the company behind Cilium. Thank you, Civo, for you guys for inviting us and the opportunity for us to talk and introduce Cilium and eBPF. My talk is about introducing Cilium and eBPF for you guys to understand what eBPF is and how Cilium is using eBPF to provide cloud-native network security and observability. Let's start with eBPF. So eBPF stands for Extended Berkeley Packet Filter, and that doesn't help much because what it actually does provides a way to provide sandboxed programs running in the kernel without changing the actual kernel. So it makes the kernel programmable without changing it. And it does that at native execution speed. What that means is that you can have any application or pods running in user space, and based on events in the kernel, you can run custom code. What's important for this session is that eBPF for Cilium will be triggering programs based on attachment points, right? So let's say a process is doing a connect call, an eBPF program can be triggered based on that process being connecting that. And then it can do things like inspecting that traffic. Or for example, when a network device starts sending network packets, eBPF can be, for example, triggered to inspect what's going on or to do some bandwidth management on that. And these are very important, flexible attachments and events where eBPF can be triggered to do a number of things on the networking side, but also provides observability for flows going through the network devices or coming from processes and sockets. So I'm not going to talk about a whole lot about eBPF and how eBPF in itself works, because Cilium basically abstracts the usage of eBPF as a open source software for providing your connectivity, your security and observability, especially in cloud native environments using Kubernetes. What this means is that Cilium as a CNI can provide services like network load balancing of network policies, load balancing, bandwidth management, flow and policy logging, ops and metrics to your workloads in your Kubernetes clusters using eBPF. So for example, you run some pods, they connect to each other, which can trigger an eBPF program to inspect the traffic and, for example, using network policies to allow or deny that traffic. So let's have a look at some of the Cilium use cases. First of all, it provides container networking and is highly efficient and flexible in terms of scalability. You can either do routing or use overlay networking, and we also support cloud provider native networking. We support both IPv4 and IPv6, as well as network address translation 4.6. And using cluster mesh, we support multi-cluster routing across clouds or on-prem towards, for example, a cloud cluster. In terms of load balancing, Cilium provides out-of-the-box layer 3 and layer 4 load balancing, and also replace kubeproxy to provide highly efficient Kubernetes services. Cilium also provides out-of-the-box north-south load balancing based on maglev. And recently we had a Servicemesh beta program where Cilium provides a sidecar-less eBPF accelerated Servicemesh solution for your Kubernetes clusters, which also improves greatly the latency and obviously avoids the sidecars, which is basically running in current service mesh solutions. In terms of security, Cilium provides identity-based network policies and Cilium network policies. We'll have a bit of a look on that today as well. And the Cilium network policies specifically also support API-aware filtering traffic like HTTP, gRPC, Kafka, Cassandra, and Memcache kind of traffic. Also providing DNS filtering, encryption using IPsec, WireGuard, and TLS termination and injection. In terms of observability, Cilium using Hubble will also provide observability in providing insight in your flows, providing metrics which you can export to Prometheus and Grafana, and supporting OpenTelemetry. Some of the Cilium users, and explaining the use cases they use, is that you may have known that Google Data Plane v2 is actually using Cilium. Adobe is using it for multi-tenancy layer 3, layer 7 security enforcement. Datadog is using it, for example, using multiple clusters and load balancing services across clusters. Or, for example, Bell as a service provider uses Cilium for high performance networking and multi-cluster solutions across hundreds of edge clusters. Let's have a bit of a basic look at what a CNI in terms of networking provides and how Cilium helps there. Obviously, in terms of Kubernetes networking, we need to provide connectivity in terms of providing pods with virtual network interfaces, assigning IPs, provide intra-node connectivity, either using overlay or direct routing. Inter-node connectivity using overlay or intra-node direct routing. Most of the time, a Kubernetes networking CNI solution relies on some kind of IP tables or IPVS implementation using proxy. And that will allow services to keep track of pods as an endpoint and updating IP tables for when pods appear and are being removed. Cilium in that sense is different because Cilium uses eBPF for all that connectivity. So Cilium runs as an agent on each node in your cluster and provides connectivity either using overlay as a default or direct routing or some kind of hybrid solution in cloud provider environments to connect your nodes in the clusters together. The data plane is an eBPF-based data plane, and that gives a lot of opportunities at scale. So therefore, we can also replace the kubeproxy as instead of using an eBPF-powered services to better perform and scale for updating your services, high churn and high scale. So let's have a look at those Kubernetes services. Typically, a service is obviously used to give a single point of entry for accessing a certain application or a certain collection of pods. So for example, app 1 tries to connect to app 2, and since pods are ephemeral and their IPs are ephemeral, you don't want to directly connect to an IP. Instead, therefore, you use a service of type cluster IP. That works, and that becomes, although, a problem at high scale, because a service type cluster IP in traditional IPVS or IP tables implementations means that every time a endpoint or service or both is being created, or endpoints are being added or removed, this basically means that the IP tables need to be recomputed and re-evaluated. So changes to a given service are not atomic. Using Cilium, however, we implement an eBPF-based per CPU hash table implementation, which means that we create BPF maps where changes are atomic. So, for example, when an endpoint gets removed or scaled down the number of endpoints for a given service, that changes are atomic and we don't need to reload the BPF map, just a change of an entry in a BPF map. In all implementations using IP tables, you know that's a linear list and all rules have to be replaced as a whole. Thinking about services and the representation of services being present on each node in each cluster, this problem at scale becomes worse, right? The number of services, the number of pods, and the number of nodes, if those objects grow in your Kubernetes cluster, that basically means at some point you will hit issues when you try to update a certain entity in your Kubernetes cluster, and it takes a long time to get updated because of this linear, non-atomic update using IP tables. So Cilium using eBPF, using BPF maps greatly enhance the performance and changes in your environment. Also, if you look at service type load balancing, out of the box, Kubernetes doesn't provide any way besides a node port or given cloud integration to attract traffic into your cluster. Cilium, however, has a standalone or distributed pod-aware load balancer as a service, which is based on maglev to attract traffic to your cluster and forward it to endpoints in your cluster. In terms of platform integration, you can start with Cilium on your MacBook or on your PC with Minikube or Kind, which enables you to quickly start and to develop applications running on Cilium clusters. Cilium can run on your self-managed clusters, bare metal, or running on VM solutions. Cilium is integrated in Amazon EKS Anywhere out of the box and is also supported in Amazon EKS. And like I said earlier, Google Data Plane version 2 on GKE supports Cilium as well out of the box. Also, Microsoft AKS is supported with Cilium. What that means is, in terms of native cloud support, if you look at Alibaba, AWS, Azure, and Google, is that we can also integrate with those VPC connectivity, meaning that Amazon, for example, is responsible for associating ENIs with the nodes, assigning IP addresses, where Cilium can then, for pods, read the usable IPs and assigned IPs running on that nodes for those pods. And therefore, the IP connectivity in your VPC is guaranteed and can be used in, for example, AWS, and you can apply security group constructs in AWS to your Kubernetes clusters. Another option is to implement some kind of CNI chaining. Maybe you have a good reason for another CNI to do the device plumbing, to do the IPAM functionality, and to provide the routing. But on top of that, you want to use Cilium for the load balancing and the network policies, encryption, multi-cluster, and visibility options, and that's perfectly supported as well. Another great feature of Cilium is using ClusterMesh, which gives you the ability to connect multiple Kubernetes clusters together. It doesn't matter if it's on the same cloud provider, on-prem, or between different cloud providers. What's important is that you have connectivity between those clusters and that you allow the required traffic, obviously, through your firewalls across the clusters, and that you have different node and pod IP CIDRs in each cluster. When you meet those requirements, what this basically means is that you can expose backends running in different clusters using a shared global service, meaning that you create availability for your services across clusters. So in this example, we have two clusters where we have a front-end deployment and a backend deployment, and the backend deployment is exposed as a global backend service using a global backend service. What that means by default is that the backends in each cluster are exposed to each other cluster as well, right? So when you access that service, you will get responses from both clusters and the endpoints in both clusters. What that also means is that for whatever reason, in this example, for example, when a backend in cluster 2 is being removed, that means that the endpoints for that backend service will be removed in all clusters and traffic will be forwarded to the remaining backends in the first cluster. Another great use case is also the ability using ClusterMesh to create a shared services cluster and to expose, let's say, a vault service for the secrets you may have in that shared services cluster to other clusters. That means that you create the shared services environment, you create a namespace, you create the service and then backends in that namespace. And for each cluster needed to access the shared services environment, you create the same namespace and just a service and in that namespace, which will then, using ClusterMesh, will learn about the endpoints and will forward traffic for those clusters to the shared services cluster. Now moving on to security using Kubernetes network policies or Cilium network policies. What's important to know is that Cilium provides identity-based security for both Kubernetes and Cilium network policies. What that means is that any given pod you deploy in your Kubernetes cluster will have some kind of label combination. Based on the unique set of labels, Cilium will create a unique identity. Using that identity, Cilium is able to attach that identity using BPF to flows from, for example, a front end to a backend. That identity will be encapsulated in the actual packet and Cilium will be able to verify that identity, for example, on the backend side when the traffic arrives and make a decision using BPF on that, right? So it can allow or deny traffic, for example, or can do different things based on that identity. Cilium is API aware. So besides the general layer 3 filtering, layer 4 filtering capabilities, Cilium provides layer 7 filtering capabilities for certain applications. So we are able to inspect HTTP traffic. We are able to filter on specific API calls, for example, only allowing a GET call on /public and deny everything else. Besides an HTTP example, this is also a Cassandra example, but it's also supported for Kafka or gRPC. In this example, we configure Cilium network policy for any endpoints matching the label app equals Cassandra, and only allowing the port 9042 as protocol TCP, and then matching layer 7 protocol Cassandra, where we only allow a query action select on the query table, my table. Another very powerful feature of Cilium is that we are able to create DNS-aware layer 7 Cilium network policies. What that means is that anytime, for example, a given pod does an API query or does a DNS query to resolve a certain domain, using BPF, Cilium is able to inspect that traffic and make decisions based on that. So in this case, the front-end pod is doing a resolve of www.mydomain.io. And based on that request, we can make decisions if that traffic is allowed. And in this case, we created a Cilium network policy allowing only egress traffic to match a name with a wildcard domain for mydomain.io on port 443 and TCP traffic. This is very powerful, obviously, for integration with applications running, for example, on S3 storage, which obviously is hard to track if you want to try that with IPs. So using, obviously, the domain name, that makes it a lot easier to filter the traffic. So in terms of matching capabilities, it's important to understand that Kubernetes matches pod labels, namespace names and labels, service accounts, and service names and cluster names. In terms of DNS, we support regex and fully qualified domain names. Obviously, CIDR blocks with exceptions, but also the ability to integrate with cloud providers as a matching capability with instance labels, VPC, subnet names and tags, or security group names. And Cilium provides also logical entities inside the cluster. So everything inside the cluster, everything outside the cluster, and things like a local host. So always a challenge when you create network policies, and specifically Cilium network policies, is the need to learn what's going on inside your namespaces and your workloads. Cilium provides a solution for that, what's called Hubble. So Hubble is our distributed observability monitoring and tracing tool to inspect flows inside your Kubernetes clusters and be able to see what's going on and to troubleshoot connectivity. Hubble consists of 3 parts. The Hubble UI, which shows dependency map for your services, shows flows. You can filter certain flows to learn more about a specific pod and what kind of traffic is entering the pod or leaving the pod, and also the ability to inspect current network policies. The CLI provides a detailed flow with extensive filtering, which you can follow, and the ability to output the flows in JSON. Hubble also provides Hubble metrics, which provides operations and application monitoring and the ability to see that data using Grafana or Prometheus. So this is an example of the the Hubble CLI. So what the Hubble CLI provides is flow metadata in terms of Ethernet headers, IP, ECMP headers, ports, and actual HTTP, DNS, or Kafka traffic. It gives visibility in your pod names, labels, services, worker node names. If you configured DNS-aware Cilium network policies, it will show you the fully qualified domain names for source and destination. And obviously the Cilium security and identities and endpoints, and any reasons for dropping or allowing traffic and policy verdict matches. So in this example, we have a simple Star Wars example with a TIE fighter and an X-Wing trying to access a Death Star. So in this case, we try to follow the X-Wing traffic based on that label. And we can see things like DNS lookups, successfully connecting HTTP requests to www.disney.com domains, and also seeing in case of trying to access the dev star, blocking that traffic because of the policy. This is a screenshot of the Hubble UI interface. So when you start the Hubble UI, you have the ability to select a namespace. And for each namespace, you can then inspect the traffic flows for the pods running in that namespace and the services which are being connected. You can also see flows coming inside the namespace ingress, but also if a pod is, for example, accessing something egress, you can inspect that traffic. And this is a great tool to see what's going on. And based on the expected traffic or not expected traffic, make network policy decisions and to tune the required network policies for your workloads using Cilium network policies. It provides filtering capabilities based on labels, based on pod. You can zoom in on a specific pod. You can filter on the HTTP status or the actual verdict like forwarded or dropped. And finally, as you may have heard, is that we also support Servicemesh. Servicemesh is recently running in a beta phase, and we're currently developing Servicemesh to a full supported feature. And what this means is that using Cilium, we provide acceleration for Servicemesh by avoiding the sidecar model, right? So Cilium is providing a sidecar-less model using eBPF acceleration. What we try to explain in this diagram is in a traditional service mesh, you would receive or send traffic on your interface on the node, which will then be forwarded to your application pod, which will be first go through the TCP IP stack for Envoy, which then will leave the same TCP IP stack and then will be returned on the loopback interface to be actually received by the application. With the sidecar-less model, we basically cut all that connectivity. So we receive the traffic using eBPF and Cilium. We can directly forward the traffic to Envoy, and we can directly forward the traffic leaving Envoy to the actual pod. So we avoid a lot of hops in the traffic in between. That means that we not only accelerate the performance of throughput for traffic using Service Mesh, that also means is that you have less overhead for actual running Envoy resources for the sidecar model, which saves a lot of resources and makes the resources available for running other workloads on your cluster. If you want to start with Cilium, I encourage you to go to cilium.io/learn, and there are numerous of ways to get started with Cilium. First of all, we have weekly interactive Cilium introductions and live Q&As with Thomas Graf, our Cilium co-creator and CTO of Isovalent. We also provide Install Fest, monthly community Install Fest, both in Europe and in America, where basically we set up Cilium using Minikube with you. We can answer questions of the setup process and do a little bit of demos, what you can do on Cilium. And there's an extensive list of documentation and tutorials on the documentation side, where you can try, for example, building examples with layer 3, layer 4, and layer 7 Cilium network policies and see how that works in action. So with that, I'm completing this session. For more information, feel free to join the Cilium Slack channel and check out the GitHub. Check out the Cilium.io website and follow us on Twitter. So thank you very much for this opportunity. And I believe there's now some time for a Q&A.
Amazing. Well, thanks a lot for the great presentation, Raymond. And we'll move on to some Q&A now. So Chad is asking, what is the speed difference between Cilium and Flannel?
So the key difference is using eBPF. Using eBPF, we are able to deal with packets in a different way and enhancing the skill and performance of your workloads on Kubernetes. And the best example is the service type, the cluster IP, where with the kubeproxy replacement, at scale, this will impact your clusters and greatly enhances the performance of the overall working in your cluster. So yeah, I mean, that's just one example. And the other is obviously, what I just shown with Cilium network policies, the ability to have more options to filter traffic just beside layer 3 and layer 4.
Awesome. And there was a question about cluster mesh, but I believe that was covered. Second, so Tuna is asking, can I use Cilium as overlay network on HashiCorp Nomad?
I haven't done it myself yet, but Cilium supports overlay using Geneve or VXLAN. So I don't see any reason why that shouldn't work.
Cool. And Afzal is asking how to choose any policy for any e-commerce applications, L5 versus L7 policy. Yeah.
So can you repeat that question? Sorry.
How to choose a policy like for any e-commerce application? I believe there's like an editor for the editor.cilium.io where you can
exactly. Yeah, that's a great call. You can start with the network policy editor. I will share that in the chat in a minute. But what I would recommend is using Cilium Hubble is to inspect that application and to see what kind of flows are going on in that application, and then you can really drill down on the components in the application and create Cilium network policies based on that, right? So you want to first obviously secure accessing your namespace and ingress both egress, right? What is allowed egress, what's allowed ingress? You need to consider DNS access using kubeproxy or the DNS access in general. So if you want to do a zero trust, you need to allow obviously DNS requests to Kubernetes core DNS. But besides that, you can then start allowing traffic. So depending on the model, you start open and secure it, or start closed and start allowing specific traffic based on what you see happening in Hubble UI, for example.